next topic is energy dissipator. So you should dissipate the incoming energy, or just the energy of the flow of water downstream of the spillway. Otherwise, erosion danger will be high. So hydraulic jump stealing basin is the first energy dissipator. So for the dissipation of excess kinetic energy processed by the flowing of water, so two common methods are adopted. The first one is by converting the supercritical flow from the spillway into subcritical flow compatible with the downstream downstream river region. So what type of river region you have on downstream of the spillway? So with that, you should make compatible. So you should convert supercritical flow into subcritical flow. So a flow is said to be supercritical if the Froude number is more than 1. Otherwise, if the Froude number is less than 1, it is subcritical. But the critical flow may happen sometimes when Froude number is equal to 1. I think you know this from hydraulics background. So the second one is just by using different buckets. If you provide bucket, as you have seen in the previous slides, then it will just dissipate the energy rather than hitting the downstream river region, just erosion danger. Then you can provide different buckets, just directing the flow of water into the air. So once it is spread in the air, then it will not damage the downstream river region. So just directing the flow of water into the air and then making it fall away, just away from the top of the structure, as you have seen from the previous slides, I think, just away from the foot of the dam structure and the spillway. So hydraulic jump type stealing basin, you have horizontal apparent type or sloping apparent type. Sometimes you may provide sloping or horizontal. So we will see the design and bucket type energy dissipators. What type of bucket you are going to use? So you may have solid roller bucket type. Solid, simply solid, just smoothly. It will have a curve, then it will jump into the air. So solid you may have. Sometimes slotted, just opening. You can provide opening at some intervals, then the energy will be dissipated accordingly. And also the next one is sky jump bucket type, which is trajectory or shooting or flip type of energy dissipator you can provide. So as you have seen in the previous slide, again, just trajectory, it will move to the air like a projectile motion. Just that is very important. So let us see. Just this is bucket type. So solid bucket type is this one, and slotted means this one. You provide slotted, just opening, then the flow is coming, then it will just hit some part going into the slot, into the hole, some part into this, then the energy will be dissipated. It will not damage the downstream river region. And also this is solid, just the flow is coming, then it will rotate, then it will go just flowing into the air. And this is a stealing basin. So this is a stealing basin. You have chutes, then you have blocks, then you may provide here baffle blocks. These are chute blocks, baffle blocks, just in a staggered manner, so that the flow is just staggering and dissipating its kinetic energy. Okay, so what are the factors affecting the design of energy dissipator? Factors affecting the design of energy dissipator. The first one is nature of foundation. What type of foundation you have at hand? Magnitude of flood and their occurrence. What is the magnitude of the flood and their occurrence? After how many years it may come? You have to know this from hydrology. And velocity of flow. This is also important. Orientation of the flow. Is it oblique or perpendicular to the axis of the spillway and the energy dissipator at downstream of the spillway? So orientation of the flow, it matters. And depth discharge and other related hydraulic parameters. Okay, so let us see. So these are just energy dissipator. So you have drop, for example. If this is upstream, you may have supercritical flow. When it jumps, then it will dissipate the energy here. Just this is the basin. So once it dissipates, then slowly it will go to the downstream part. So you may provide here sloping, just stone pitching with masonry, cement plaster. And these are just drops. Just in a stepped manner, you can provide energy dissipator. This is drop, 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 drop. Then it will dissipate, then slowly it will go to the downstream part. And this is also similar, you can see. Once you provide chute, you may have energy. Then it will go, then drop the first one, then when it goes to the second, when it goes to the next, etc., just the energy is dissipating. It will not affect downstream part. Actually, this is just for canal. For canal, you may provide drops, irrigation canal or power canal or any water supply, municipal, etc. You may provide. So this is just the chute block. So you may provide chute blocks like this, staggered manner. When it hits this one, then it will dissipate the energy, then it will go to the downstream part. Okay, so hydraulic jump equation for rectangular section with pre-jump and post-jump. So you might have learned in hydraulics 2 these equations, I think, for open channel. So this is just sequent depths just after jump. This is pre-jump. So y2 over y1 half -1 plus square root of 1 plus 8f1 square. So this is Froude number in the upstream portion. So you can provide for rectangular portion of spillway structure and energy dissipator. You can use this equation again. So Froude number, you can substitute q square over gy1 q. How do you get? Froude number means v over square root of gy. So you can proceed. What is just v? Or just discharge intensity, you know, discharge intensity. Discharge intensity small q is given as total discharge divided by the depths, the width. So q over b will give you discharge intensity small q. So you can provide like that and substitute. So specific energy also, this is the depths plus kinetic head. Since you have depths plus kinetic head. So alpha is just energy correction factor. So average velocity is q over area. So just if you substitute q over area here, then q means small q times discharge intensity times the width of the spillway. Then area means width times depth. Then v cancel. Then q over y. So if you substitute in place of v, q over y, then you can get in place of Froude number automatic. You can get this equation: q square over gy1 q. You can get. So accordingly, you can. So you have to calculate the downstream depths post jump. Okay, dam outlets, sluiceways, intakes, gates, and valves. So let us see now. Bottom outlet works are constructed, one, in order to ensure conveyance of water from the reservoir into the lower part, downstream of the dam. So this is important. Bottom outlet you have to provide. The next one is in order to facilitate lowering of the level of the reservoir. So if you need to lower the reservoir level, you can open the bottom outlet. This is also important, lowering. And to ensure water for the biological minimum in the river bed downstream of the works. So to maintain the ecological balance of the river, you can open just downstream, just you can open the bottom outlet. Then flow is releasing, then it may just feed downstream fish or other organisms. So downstream ecology will be balanced. Okay, the next one is according to their position in relation to dam, bottom outlet works are classified into two groups. So you may have two groups of bottom outlet. Let us see. Outlet structures passing through the body of the dam. Sometimes outlet structures may pass through the body of the dam, or outlet structures that are placed in the bank outside of the dam, outside of the body of the dam. Sometimes you may provide. So you can see this is through the body of the dam. So this is outlet structure, bottom outlet structures through the body of the dam, but sometimes outside in the bank. Let me show you. Okay, in the next slide. Okay, intakes, I think this is also important. Without intake structure, you cannot convey water to any purpose, for hydropower, for irrigation, or for water supply, or municipal, or agricultural demand, etc. You have to provide intake. So intake structure or head regulator is the hydraulic device constructed at the head of an irrigation power canal or tunnel or conduit, just at the head. So the main purpose of intake structures are, the first one is to admit and regulate water from the source, and possibly to meter the flow rate. If you need to meter the flow rate, you can provide this intake to minimize the stealing basin, the silting of the canal, to minimize the silting of the canal. This is also important, to minimize the silting of the canal, to control sediment entry into the canal at its intake. So in the intake, you may provide trash rack, which is wire mesh, using reinforcement bars, so that fish could not enter, and debris, trashes, and boulders should not enter to the power canal or irrigation canal or tunnel conduit, etc. So you have to provide what? Some source of sediment entry, controlling the sediment entry into the canal. So the other thing is intake to prevent clogging or blocking of the entrance with floating debris. Sometimes floating debris may come. So if you have intake structure, then you can just control on that. It will not enter to the power canal. So let me show you. So these are just intakes, tower intakes. So you may have different tower intakes. You may have different 2 or 3, just different service intake or main intake, emergency intake you can provide. So these are just walkway you have from this dam crust. You come, then you go inside, just for inspection purpose. You go inside, there is a tower, then you can just maintain and also inspect, etc. This is also similar, you can see. And this is just a pump, just for pumping. This is also intake structure with pumping. And this is intake with trash rack. So just to block floating debris, you provide just grids and also reinforcement bars, wire mesh. Then debris and other trashes will not enter to the power canal or conduit. Okay. The other thing is fish passing facility may be provided. Sometimes fish may enter. So just if you need to harvest these fishes to other direction rather than going into the conduit, you can provide facilities. So facilities for upstream sometimes migrant fish, consisting of fish ladder, fish locks, or tramways and arrangements for trapping and tracking of the fish you can provide. So the second one is special facilities for a safe passage for the migrating smolts, which consist of arrangement to collect the migrating fish in the forebay. So you can see now. So rather than going to the conduit, you can just track these fishes going then into downstream reservoir. Then from this you can harvest. And this is also, you can see with intake, they may enter to the turbine. So this is dangerous. Without this, it may be difficult. But if you close the gate valve here, gate valve you have, then you can just take here, then collect. Let me show you with photo. So this is just a dam structure, which is gravity dam, concrete gravity dam. So with different radial or just sluice gates, spillway gates different, then you may provide in the other direction fish ladder. So fish may be trapped here, then you can use just for food. I think this is a best example for fish ladder. So fish ladder should be provided if you have just fish production strategy. Okay. So the next one is gates and valves. Gates and valves are main components of dam outlet works or ancillary structures. So the main operational requirements for gates and valves are just control of floods. Just you can open, just opening and closing of the valves. So, but sudden closure and opening may not be feasible sometimes. During just sudden opening of the valves, sudden closing, just water hammer may create. Just it may go back then it may just, if the penstock is not strong enough to withstand the internal pressure, which is laterally, just it will be damaged, then leakage may happen. So the control of fluids, water tightness, minimum hoist capacity, convenience of installation and maintenance, and above all, failure-free performance and avoidance of safety hazard to the operating staff and the public. So control of flood, just water tightness, you can provide gate valves. So gate valves are divided into crust gates or high head gates and valves. Sometimes radial gates, crust gates, just rectangular, just you can open, close, you can just accordingly you can control. So this is important, gates and valves. I think. And thanks for watching this video. So this is all about today's lecture. Hopefully you liked the video. If you have any comment or question regarding this topic, please write down in the comment section below.